Best rice farming practices strategy number 6 is integrated pest and disease management. Understanding why SRI reduces pest and disease pressure. One of the most remarkable and economically significant benefits of proper SRI implementation is that pest and disease problems typically decrease substantially compared to conventional rice farming. After reducing pest requirements by 50 to 80% or eliminating them entirely, generating cost saving of between $40 to $100 per hectare, while also reducing health risks and environmental impacts. This pest and disease suppression results from several SRI principles working synergetically. First, healthy, vigorous plants resulting from optimal spacing, nutrition, and water management possess better natural resistance to pests and diseases because they allocate adequate resources to defensive compounds, maintain thicker cell walls, and wax cuticles resistant to pathogen penetration, and recover more quickly from pest damage. Second, wider plant spacing improves air circulation within the canopy, reducing humidity and creating less favorable conditions for fungal diseases that thrive in humid, stagnant conditions, typical of dense conventional plantings. Third, alternate wetting and drying breaks the life cycle of many rice pests and diseases that require continuous flooding. Some insect larvae, like snails and disease organisms, cannot survive drying periods, reducing their populations without any pesticide application. Fourth, the enhanced soil biological activity resulting from aeration and organic matter supports beneficial microorganisms, including predators, parasites, and antagonistic microorganisms that provide natural pest suppression. Fifth, mechanical weeding removes alternative host plants that harbor pests and disease early in the season before rice plants are vulnerable. The scientific documentation of reduced pest pressure in SRI system is substantial and consistent across studies from many countries. Research consistently shows that SRI fields experience between 30 to 60% less pest damage and between 40 to 70% less disease incidence compared to the adjacent conventional fields, with particularly dramatic reduction in stem borers, leaf folders, brown plant hoppers, bacterial leaf blight, and sheath blight, some of the most economically damaging rice pests and diseases. Some research suggests that the silica uptake enhancement from improved root development strengthen plant cell walls, making leaves and stems more resistant to insect feeding and fungal penetration. The practical implementations are profound. Farmers implementing SRI comprehensively and typically find that what were previously major pest management headaches requiring multiple pesticide applications become minor issues requiring only occasional monitoring and rarely requiring treatment. This doesn't mean pests and diseases disappear entirely. They don't, but they remain at the background levels below economic damage threshold, allowing natural biological control to provide adequate suppression without chemical intervention. Let's look at implementing integrated pest management practices. Even with SRI's inherent pest suppressing effects, implementing complementary IPM practices provides additional protection and further reduces pest-related costs. First, scout fields regularly. Do weekly during vegetative growth, twice weekly during productive growth. Walking systematically through field maximizes examining 20 to 30 hills or plants distributed across the field, counting pests, insects, examining leaves and stems for disease symptoms, and assessing damage levels. Compare observations to established economic thresholds, the pest population level above which control costs less than expected crop losses. For example, stem borer treatment is typically justified when 10 to 15% of plants show dead heart symptoms in vegetative stage or whitehead symptoms in productive stage, while lower infestation levels don't economically justify treatment. Many farmers spray preventively without ever checking whether pests are actually present at damaging levels. This wastes money and creates resistance, while systematic scouting ensures you only treat actual problems. Implement cultural practices that reduce pest pressure. Practice crop rotation where possible. Alternating rice with other crops will break specialized rice pest cycles. Time planting to avoid peak pest periods. Local agricultural extension services can provide guidance on pest phenology in your region and maintain field sanitation, removing heavily infested plants or diseased tissue, preventing pest multiplication. Use resistant varieties where available. Many modern rice varieties incorporate genetic issues to specific diseases or pests, providing durable protection without any additional management. Encourage and protect beneficial organisms that provide natural pest control. Avoid broad-spectrum insecticides that kill beneficial insects along with pests. If chemical control becomes necessary, select targeted products with minimal non-target impacts. BT products for caterpillar pests, neem-based products as alternatives to synthetic pyrethroids. Maintain field borders and barns with flowering plants that provide nectar and pollen for beneficial insects, and recognize that some pest presence is acceptable and even desirable because it maintains beneficial insects population. The goal is not zero pests, but keeping pests below economic damage threshold through integrated tactics. For disease management specifically, the most important practices are preventing conditions favoring disease development, maintaining proper plant nutrition, neither deficient nor excessive, as both extremes increase disease susceptibility. Ensure good field drainage, preventing standing water during drying periods of AWD. Standing water can promote some diseases. Maintain wide spacing, improving air circulation, and reducing humidity within the canopy, and use certified disease-free seed. And using certified disease-free seed, which will reduce and it will keep reducing introduction of seed-borne diseases. Most rice diseases are favored by specific environmental conditions. For example, sheath blight requires high humidity and dense plant canopies, while bacterial leaf blight requires wounds for entry plus warm humid conditions. And avoiding these conditions provide effective prevention without fungicide. Many SRI farmers report that after 2 to 3 seasons of implementation, they rarely see significant disease problems and apply no fungicides compared to conventional systems requiring 2 to 3 fungicide applications costing between $40 to $80 per hectare. Best rice farming practices strategy number 7.